Welcome to IS250. I'm Professor Fahmi Jalani. Today we'll be covering chapter 17, searching and sorting algorithm. Take note, this will be our last chapter for the semester. So let's begin. So in part 1 we have searching and algorithm. This technically is a sequence of steps of when accomplishing a task. Linear search example is a search algorithm that starts from the beginning of a list and checks each element until the search key is found, or at the end of the list is searched. Okay. This example, the program here looks for the value of 10 and it's later found at index 301 to 3. Next we have binary search. In the previous example, linear search, they require searching all the list of element. In this case, for example, in your smartphone, you will search one by one from first to the last, and this could be time consuming. So in order to do a faster search, we could use a binary search, okay, which is a faster algorithm for searching in a list. Okay. The same example we have here, but on a different code, we have a binary search here, okay, which would search the key less than the middle element, okay, or the remaining right sublist. Okay, in this case, if the search was greater than the middle element, okay, it will compare, right, in the list. In this case, mid, low, and high. Next, we have O notation, or big O notation, mathematically way of describing how function running. Okay, so basically it's the same growth of rate function by the highest order terms. Okay, and over here we see the algorithm steps and big O notation, which we elaborate later on in the next slide. Okay. Here we see the comparison of composite and big O notation. In this case, for example, C multiplied by O notation fx is basically big O notation. Okay, and we have other growth of input size. So we have a runtime complexities, okay, in pseudocode example. Okay, in this case example you have and big O notation 1 constant. This is basically the pseudocode that we'll be using. Okay. It goes for log n and log n squared and c to the power n exponential. In terms of analysis algorithm, to analyze how runtime of algorithm scale as the input size increase, we determine how many operations the algorithm execute for specific input size n. Okay, then the big O notation for the function is determined. Algorithm runtime analysis often focus on the worst case scenario complexity, as you can see from this example. Okay. The worst case runtime of an algorithm is the runtime complexity of an input that result in the longest execution, which if you have an infinite loop, for example. Other runtime analysis include best case runtime, average case runtime. Determining the average case runtime acquires knowledge of statistical and properties of expected data input. 17.5 we have sorting. Sorting technically basically is a process of converting list of elements into ascending or descending order. Here the example is basically to sort from small to big or ascending order, okay, which is quite common. Other than that, we have insertion sort. This is basically a sorting algorithm that treats the input as two part, okay, sorted part and unsorted part, repeatedly inserted. Repeatedly inserted the values from the unsorted part into the correct location of the sort part. 17.8 we have a quick sort, which is quite unique. A sorting algorithm that repeatedly partition the input into low and high part. Over here we see the initial value 7, 4, 8, 6, 18, 8, where they are being partitioned into, in this case, two part, 6 and 4, where they are being sorted. Okay, and then accordingly, and then 7, 8, 18 and are being sorted. And at the end, once they've been sorted, they have been listed out. Okay. So the pivot point could be any value in between. Okay, in this case 6, 7, 6, 18. And last but not least, we have merge sort. We in merge sort is basically sorting algorithm that divides into two lists or two halves. Okay, here we have 0 to 5 index, or 3, 11, 8, 18, 4 and 25. The half of it is being divided, and from there another half, and once they are being separated, they are being sorted back in the reverse manner, where in this case ascending order. Okay, so that's pretty much it for the class for IS250. It's been a pleasure teaching you guys despite some challenges in the beginning, and other than some of the reviews online. I hope to see you guys again. Those of you who are planning to major in programming, do take note that um, that to be aware of the topics and also the professor that we teaching. That I think by now you would understand that different professor has different style of teaching, and appreciate you would not compare any of the style within any of the professor, and including me too. Okay, I wish you best of luck in the upcoming semester or courses and exam, and thank you very much. Do feel free to email me or set up an appointment, um, and also be diligent in programming, especially the syntax, and and to be a good programmer you need to have practice and patience especially. Stay safe and bye bye. Thank you.